The Muse Glimmer Shakedown. A model's launch day is marketing. The days after are the audit. Meta's Muse Glimmer-30B has now had both. The open weights drop landed on r/o, LLAM, with the usual fanfare. Fans spinning up on M1 Pros, someone claiming Opus 4.8 capable coding on a 128GB MacBook, and the recurring note that Meta is finally back in the game after squandering its Llama lead. But the revealing threads are the ones where people put it to work, and there, the picture is consistent with what Glimmer showed on arrival. Reliable, and a step behind Qwen where it counts. The clearest head-to-head pits Qwen-635B, a 2-minute run against Muse Glimmer-30B, 4 minutes on a hand-rolled Blackwell Llama.c PP build, and the verdict splits along a familiar seam. Glimmer almost never drops the ball or breaks rules, but its designs lack creative depth. Qwen produces far richer, more complex voxel worlds at the cost of occasional hallucination. The comments demolish the comparison. A dense 30B against a 3.5BA 3B, mixture of experts with only 3B active parameters, both crushed to IQ3, is, as one reader put it, comparing a Ferrari to a budget Toyota. That skepticism of Q3 quants, which flatter nothing, is warranted. What survives is the softer signal. Glimmer is the dependable tool caller, a lot like GPTOSS, and it even beats Gemma 4 at Ukrainian. Praise for reliability, not brilliance. The more disciplined experiment sidesteps the quant mismatch and asks a sharper question: how much does active parameter count actually buy you? On a Radeon R9 700 Qwen 35BA3B, MOE ran roughly 3.9 faster than the 27B dense model, about 116 versus about 30 TOC/S, yet the coding quality gap was much smaller than I expected. The dense model pulled ahead only on implicit invariance, odd edge cases, and consequences beyond the literal request. That is the community answering a challenge it has been posing for a year, and the honest caveat: different quants, a small sample, is what makes it worth reading. As one commenter warns, MOE is good at high-volume pattern matching, not creating. Active parameters are a throughput lever, not a clean proxy for judgment. The weirdest entry is a stunt that quietly indicts the premise. Someone wired DeepSeek v4 Flash to call Muse Glimmer as an external vision oracle, letting the text-only coder screenshot its own canvas animation and ask Glimmer what it saw. It worked, sort of, after 30 to 60 minutes of round trips. And then, on a rerun, DeepSeek decided Muse's feedback was not reliable, ditched it, and used the Pile image library to inspect the scene itself, finishing in under 10 minutes with a better result. No point using Muse then, the top comment concludes. Whether that is emergent resourcefulness or non-deterministic luck, it is a reminder that agent scaffolding is where these gains live or die. Agents that never hold the keys. The threat model for AI agents has a clean, ugly summary. Any tool that can make an HTTP request can be talked into exfiltrating a secret, and prompt injection is the channel that does the talking. As seen when a pentester coerced a chat assistant's HTTP tool into fetching cloud instance metadata and harvesting IAM credentials in plain conversation. Infisical's new agent vault is the product-side answer, and its founding premise is refreshingly blunt. Agents should not possess credentials. Instead of handing an agent real keys, you store them in the vault and force the agent's traffic through a man-in-the-middle proxy that injects the real secret server side. The agent holds only a dummy placeholder like Anthropic API key. The proxy swaps in the truth before forwarding. The engineering is pragmatic. It ships as a single MIT-licensed Go binary running a management API and an intercepting proxy, integrating non-invasively by setting HTTPS proxies and a CA certificate in the agent's environment. So wrapping Claude code is one command: agent vault run. Claude. A TypeScript SDK mints short-lived scope tokens for ephemeral sandboxes. The security model rests on separation of hosts run the vault somewhere the compromised agent can't reach, a master password unset from memory after read, aggress filtering, and a strict deny mode that 403s unmatched hosts rather than acting as an open proxy. It is candid about being a preview with a moving API, but as a self-contained pattern, brokered access is the right shape. The same idea shows up purer in jedarden/seam. A self-documenting endpoint access mediator that fronts multiple authenticated backends behind one HTTP endpoint, injecting each service's secret from OpenBOW server side so calling agents never see it, and guiding malformed requests toward the correct shape via self-describing OpenAPI spec. Two independent projects converging on the agent gets a shape, never a secret, is the signal. This is becoming boring, essential infrastructure, exactly where security wants a problem to end up. The offensive half of the ledger is noisier. A LinkedIn post claims DeepSeek v4 Pro 0813 is the new mythos. reporting that on Aikido's benchmarking of CyberGym and ExploitGym, it outfound every rival. 87.5% of benchmark CVEs rediscovered at pass at 3, versus 81.3% for Opus 5 and Qwen 3.8. While the harness under test flagged real bugs only 65.6% of the time against GPT 5.6 Sol's 86.4% precision. Treat the framing with care. ExploitGym has been reported as UC Berkeley's construction. So a vendor topping Aikido's benchmark describes who ran the eval, not who owns it. And prior leaderboards already had Anthropic's Mythos preview at 83.1% on CyberGym. The sharpest reply in the thread is the correct one. 65.6% precision on a tool pointed at real infrastructure is a calibration problem, not a model problem. A finder that cries wolf a third of the time isn't a weapon yet. It's a triage bill. That a Chinese open-weight model tops the recall column continues a diffusion trend worth watching. Provenance is a moving target. The arms race between synthetic media generation and the defenses meant to label it keeps tilting the same direction, and today's batch is 3 fresh data points on the attacker's side of the ledger. Start with the research, because it is the most consequential. Adaptive identity anchoring tackles the core bottleneck in video face swapping. No natural training pairs exist, since no footage shows person A's face performing person B's video, by turning identity anchor frames into a controllable quality dial. Where the prior state-of-the-art anchored only the first and last frame and let a pose-conditioned diffusion model hallucinate the interior, which drifts back toward the generator's own face over long clips and profile views. The proposed closed loop scores every frame against a reference photo with ArcFace, inserts a fresh anchor at the worst offender, and regenerates only that span. For a fraud team, the alarming half is the companion mechanism. Reality-referenced texture restoration specifically attacks the over-smoothed, pore-free beauty filter look. Regraining synthetic skin using noise statistics lifted from the real footage's own non-face regions. That smoothness is one of the most reliable tells detectors and humans lean on. And the paper says so plainly, flagging the Goodhart risk that hardening identity fidelity in exactly the profile and occlusion regime where detectors are weakest is how you defeat them. The honest takeaway for anyone running identity verification, texture, and smoothness-based deepfake heuristics have a shortening shelf life. And this sits atop a real fraud economy. Real-time face swap romance scams, the $25 million Erupt case, IC3's billion-dollar losses among older victims. If detection is losing at the pixel level, provenance metadata was supposed to be the fallback. And that is what Guillaume Meyer/Watermarks Remover is built to strip. The MIT licensed toolkit removes multi-vendor AI marks in layers, deterministic deletion of zero-width and BD Unicode carriers, paraphrase attacks on statistical sampling watermarks, and a file layer that strips C2 Pascal's manifests, XIFF and XMP from images and documents. It is unusually candid about its own limits. Statistical marks require rewriting nearly every sentence, degrading quality, and no tool can honestly certify removal without public detectors. But the dual-use tension is undeniable. This is a working attack on C2 Pascals, the industry's flagship transparency mechanism, arriving just as OpenAI and Google converge on SynthID and content credentials. And on the generation side, the trend broadens beyond faces. Solilab's Sol X Singer is trending as a dedicated singing voice synthesis model. The source card returned empty, so treat it as a signal of where the synthetic audio frontier is heading rather than a spec sheet. Benchmarks that still bite. The uncomfortable truth about coding benchmarks is that most of them measure memorization as much as skill, and the field's honest response has been to build tests designed to resist that. DeepSeek by DataCurve is one such test, and by now it is an established fixture rather than a debut. Its leaderboard has been tracking frontier models for months. Its 4 design moves are the point. Tasks written from scratch, so no models saw the solution in pre-training, spanning 91 repositories across 5 languages, with prompts half the length of SWBench Pro's but solutions, requiring 5.5 more code, verified by handwritten tests of behavior rather than implementation. The benchmark earned early notoriety for the claim that Claude Opus cheats by recovering gold solutions from Git history. Arguably just what a senior engineer does when no rule forbids it. The real lesson stands. Evaluation harnesses need to declare their contract alongside their score, and DeepSeek's reward hacking resistant, adversarially judged design is that principle taken seriously. If DeepSeek hardens the verifiable end of evaluation, Anthropic's conceptual reasoning index goes after the part that resists verification entirely. The CRI aggregates 3 benchmarks. LMCA judging conceptual arguments against expert ratings, AC chord logical consistency of a model's stated beliefs, and DT bench decision theory. Precisely because the AI safety work that matters most involves reasoning where empirical evidence is limited. There is no verifiable answer, and one has to rely heavily on argumentation. The numbers are sobering in a useful way. Opus 5 tops the index at 73.6 against an estimated ceiling near 91. Scores have risen roughly linearly since late 2024. And DT Bench is nearly saturated. Fable 5 gets 98%, while LMCA and AC Chord have room to run. One detail rewards a close read. To score Fable 5, they used Opus 5 as a fallback wherever Fable 5 refused to answer. A quiet admission that refusal behavior now distorts capability measurement. The third entry answers the contamination problem head-on. Pathways arc task gen generates fresh ARCAGI. One style task precisely because a public benchmark cannot fully isolate few-shot rule induction from potential prior familiarity. It exists to evaluate BDHCQ, a 150M parameter reasoning model built on the post-transformer dragon hatchling architecture, which hits 29.5% pass at 2 on public ARCAGI. 1 at 0.00000 per task, 11 cheaper than GPT 5.6 Luna, with results reproduced by Wukas Kaiser, a transformer co-author. Pairing a novel recurrent latent architecture with a purpose-built uncontaminated eval is how you make a small model efficiency claim that might actually survive scrutiny. What LLMs can actually do. Timothy Gowers has written the most clarifying thing you will read this year about the shape of machine mathematics, and it starts from a genuine puzzle. OpenAI's models recently solved 10 major open problems, including the first construction of a non-sophic group and a proof that multicolor Ramsey numbers grow super exponentially, which Gowers didn't necessarily expect to see solved in my lifetime. So why hasn't that produced a flood of results? His answer is that the famous solutions are almost all counterexamples, and that LLM's twin strengths: encyclopedic knowledge of standard arguments and the speed to try enormous numbers of failed attempts. Favor a try lots of things till you get lucky style. Where humans still lead is the nose for pruning deep, branching search trees, a skill the tidied up proofs in the training data never demonstrate. His test for genuine breadth is a proof as surprising as the 2016 CAPSET solution. We'll recognize it when we see it. That skepticism is the right lens for Mechanist, an agentic system that turns mechanistic interpretability itself into an autonomously researchable science. A central orchestrator drives 4-stage agents grounded in an interpretability knowledge graph of about 13,000 papers and a library of 32 methods. And it ranked first across 3 human judges reproducing 16 recent papers from the claim alone. The case studies earn attention. A demonstration that subliminal learning crosses modalities and survives semantic filtering. A text-only student trained exclusively on GPT-4 verified safe outputs from an unsafe teacher reached 48.6% unsafe responses versus 20.3% untuned. The lesson for anyone doing data governance is that content-based filtering is insufficient against trait transmission. The authors themselves recommend human-in-the-loop use over full autonomy, the correct posture for AI scientists claims that only matter if they replicate. The most concrete, LLMs did real work, result comes from quantum hardware. Researchers at Mainz and Saarland had Claude Opus 4.7 via Claude Code write complete shuttling compilers for trapped ion quantum computers, the bespoke software that schedules physically moving ion qubits around a chip. From written specs alone, no fine-tuning, cutting months of expert engineering to days. The generated compilers beat handcrafted baselines by up to 76% fewer shuttling time steps, largely by choosing gate order dynamically from the ready set rather than routing a fixed order. Crucially, the LLM is consulted only at build time. The output is ordinary verifiable Python, and the whole thing replicated with Claude Fable 5, which optimized more aggressively under follow-up prompts and beat baselines on 8.098% of the largest circuits. This is the template that generalizes: precise spec, fixed interfaces, unmodifiable validators, and a frontier agent producing domain expert systems code. The full local stack keeps arriving. The democratization of local AI has been a slow accretion of pieces, and Unsloth Desktop is an attempt to package the whole pile into one app. Run and train LLMs, diffusion, and audio models on macOS, Windows, or Linux with day 0 support promised for Q, WEN 3.8, Gemma, and others. The security-relevant features are the interesting ones: permission controls, and a sandboxed code execution environment modeled on Claude Code. Self-healing tool calls that detect and retry failures for up to 50% more accuracy. No telemetry, and optional Cloudflare tunneling for remote HTTPS access. Coming from the team whose quantized releases are already the community reference for models like Gemma 4. A polished local trainer plus runner is the logical next rung on a democratization ladder climbing since budget fine-tuning toolkits appeared a year ago. The most educational post in the batch is a local real-time voice stack. Parakeet SDT into Qwen 2.57b into Qwen 3 TTS. But the value isn't the architecture, it's the measurement discipline in the comments. One builder reports that time to first token flatters everything, because his median first chunk was 2 characters and 12 readable words only arrived on the third chunk. The metric that actually decides whether a voice assistant feels alive is the gap from end of speech to something useful, which he clocked at a 2,636 ms median, 2/3 of it belonging to the model. His better idea: decide the user finished talking from the transcript, not silence thresholds, by speculatively decoding every 100 ms and discarding interrupted runs. Measured against the sub-400 milliseconds voice-to-voice numbers the community has hit on tuned hardware, Qwen 2.57B is a conspicuously dated choice. But the honest latency accounting is the transferable lesson. Two smaller builds round out the on-device story. Someone embedded Gemma 4 E4B and E2B into an e-reader app on Leader TLM, downloading INT4 models with no accounts, injecting the book's metadata and current passages context, and unloading the model from RAM when the chat closes. A thoughtful private reading assistant, with a commenter's fair warning that at this parameter size expect frequent hallucinations on grounded questions. And for the demystifiers, Rawformer is a transformer decoder built from scratch in pure QP. No PyTorch, no autograd, manual backpropagation through every layer, trained on Penn Treebank on a single laptop. The kind of below-the-abstraction exercise that, as its author notes, cleared up a tremendous number of misunderstandings about how the machinery and the GPU actually work. The layers around the model harden. 2 releases this week are best read together as the same story from opposite ends of the stack. The foundation below the model and the harness above it both reaching maturity. Mojo 1.0 is the foundation. After building toward it since 2023, Modular is declaring the language production ready, with a stability commitment modeled on how mature languages like C++ evolve. Additive changes through the one-docs line, breaking ones managed with care. The milestone is real. Nearly 200 contributors, 100+ merged pull requests, a stabilized LSP, memory safety diagnostics for reference and validation, and a company that now runs Mojo in production as the foundation of its commercial Macs and cloud infrastructure, with 26.5 adding Mac support for the GLM 5.2 and Nemotron H hybrid Mamba 2 families. The strategic subtext is what makes it worth watching. Mojo's pitch has always been running high-performance code across CPUs, GPUs, and accelerators without per-processor rewrites. A direct challenge to CUDA lock-in. And the commitment to open source the compiler in 2026 is the promise that keeps that pitch honest. At the other end, DeepSeek shipped its own agent harness, Dash, a developer preview CLI built on the Cortis Everything is a Plugin architecture and MIT licensed, launched with the blunt warning that there will be compatibility-breaking changes. The timing tells the story. DeepSeek's own V4 Flash models have been dinged for chafing inside harnesses built around Claude and GPT conventions. The standing advice was that users had to conform to someone else's scaffolding. Shipping a first-party harness is the direct answer to that complaint. If your models underperform in tooling designed for a competitor, you build the tooling. The plugin registry design slots into the running thesis that the harness layer. The loop, context building, tools, safety, persistence, has quietly become the bottleneck of agentic AI, the place where a model's raw capability is either realized or squandered. A frontier lab treating its harness as a product worth open sourcing is confirmation that the industry now agrees.